So good afternoon, my honors algebra students. Thank you for being nice to Mrs. Wu today in class. She seemed to have a good experience, so I appreciate that. And I just want to be able to not waste Monday afternoon after school homework time. Instead of giving a day off, I'm going to try to record a quick 10-minute video to introduce you to 1.8. And then tomorrow in class we can actually spend time starting on your homework, which means tomorrow night you won't have potentially no homework to do, and you can go to the Spiritual Life Week session for Tuesday night. So before I go into 1.8, Mrs. Wu said there's still some questions about 65 from 1.7 homework. Why the answer is $300 instead of 10. So let me just kind of fast forward a little bit and skip ahead. You should already know that you can take the original function and turn it into standard form. And then by using completed squared, you can turn it into vertex form. This is actually minus 20x plus 8,000. If you remember from doing the homework, this is plus 100, and this is actually plus 1,000, which leave you with negative 10, x minus 10 squared, plus 9,000. So this is the maximum revenue, and it will be maximized when x is equal to 10. Now the questions that she figured out how to answer when you're doing your quiz, so she didn't get to explain it to you, is that this 10 means how many times you increase the price by $10. So this 10 means that we're going to increase $10 10 times. So 10 times 10 is increasing by 100. And since the original price is 200, 200 plus 100 equals to 300. And that's why to answer the question completely, instead of saying x is equal to 10, you have to say that you maximize monthly revenue by charging 300, which is $100 more, which is 10 times of $10. Okay? Let's move on to 1.8. 1.8 is a quadratic function. Most of you already know this and memorized it. And if you did your homework last night, or I guess over the weekend, where you have to use completed square to figure out the quadratic function without the variable a, I believe that was number 53 or something, then you have some idea of how they arrive at this quadratic formula. So instead of going into explaining how we get there, let's go ahead and just do some problems. So first thing you need to do is turn it into standard form. So move everything to one side. Notice I changed it to a minus 2 because I move it over. And then you simply have to plug into the function negative b plus minus b squared minus 4ac over 2a. And you're going to write x equals, which means this is x equals to negative 3 plus minus square root of, this is these two cancel out, so that's 8, that's 17 over 2, which means x is equal to negative 3 plus minus root 17 over 2. So what that means is that when you these are the two x values. Again, there are two values here. These are the two x values that made the statement x squared plus 3x minus 2 equal to 0, which also means that they are the x-intercepts. And if you punch this into the calculator, you get 0.56 and also negative 3.56. And you'll notice that when you graph it on the graphing calculator, those are the 2 point of x-intercept. So make sure you understand that when you use a quadratic function, your goal is to make the standard form equal to 0. So you're looking for the intercepts, you're looking for the roots, or you're looking for the zeros. They all mean the same thing. Example 2, it's just a little bit more complicated, and then you have, so let me move everything to the left again. 25x squared, this time is minus 30x plus 9 equal to 0. Again, you're going to plug this whole thing into the quadratic function, which looks like this whole thing, and then this, when you multiply it out, happen to equal to 0, which means this is x equal to 30 plus minus 0 over 50. Since the plus minus 0 doesn't matter, this is the same as 3 over 5. Which means instead of having 2 zeros, this only has 1, which means the graph actually looks something like this, where there's only 1 0. And you know that this only happens when the original standard form is actually a perfect square. This is actually 5x plus, minus 3 squared equal to 0, which means x is equal to 3 over 5. So you can actually solve it by factoring using perfect squares, but quadratic function will work just as well. This is also a good time to point out that you only get 2 solutions. So let's go back to example 1. You only get 2 solutions when you actually plus minus something inside a radical. Then you end up with 2 solutions. If what's inside a radical is 0, which means you are not going to plus minus anything, then that means you only have 1 solution. Example 3 is when you're going to have imaginary solution. So go ahead and try this by starting with turning into standard form. So plus 4x minus 5 equals 0. Plug it into the quadratic function, which looks like that. And when you simplify what's inside a radical, you get a negative 4 over negative 2, which means you have negative 4 plus minus 2i over negative 2. You can divide everything by negative 2. You end up with positive 2 plus minus I, which means your solution, the zeros for this function, is 2 plus imaginary number I and 2 minus I. If you actually graph this function, it will look something like this. It will never actually cross the x-intercept, which means there are actually no zeros. That's why the roots, or when you solve quadratic function, you end up with imaginary numbers, because there's not actually no solution. Here's some guided practice. Let's try number 1. You can pause the video, try it on your own, and then I will do it and show you the steps. Okay, so go ahead and pause it and come back when you're ready. So number 1, first change it to standard form. Plus 4 equals 0. Make sure you change all the signs. Plug it into the quadratic formula, which is negative b, which is plus 6, plus minus b squared minus 4 times a times c over 2a. So the a is 1, b is negative 6, c is 4. This is equal to 6 plus minus 36 minus 16 over 2, which is equal to 6 plus minus square root of 20 over 2, equal to 6 plus minus, this is 4 times 5, so 2 root 5 over 2, equal to 3 plus minus root 5. Okay, because this is 20 inside, so you're actually adding something plus and minus, which means you have 2 solutions. Okay, the reason why I keep emphasizing what's inside the radical, because what's inside the radical has a name, is called a discriminant. And like I said before, if your discriminant, what's inside, is bigger than 0, that means you're going from the axis of symmetry, going left and right by a certain distance, which gives you 2 intercepts. Or if it equals to 0, that means you're right on the axis of symmetry. You're not going to the left or right 0 by any distance, so that means there's only 1 intercept. And when you have negative, that means you end up with a negative radical, which means imaginary, which means that it doesn't have a x-intercept. So there are going to be some questions on the test where it simply give you an equation, and then you have to just tell me, without actually telling me what the solution is, that's extra work, just tell me how many solution or how many x-intercept it will have. So for number 1, you just have to do b squared, so that's negative 8 squared, minus 4 times 1 times 16, which is equal to negative 4, which means you know that a is 2 imaginary solution. Okay, number 2, you also have negative a squared minus 4ac, which gives you exactly 0, which means b has 1 x-intercept, or 1 solution. And then c, you have negative b squared minus 4ac, which is equal to 4, which means there are 2 real solutions. I think this is pretty straightforward, so I'm not going to ask you to do any of the guided practice. Let's go ahead and move on to the word problems. At this point, you should be familiar with the free fall equation. H equals to negative 16t squared plus vt plus h. The only thing they're introducing now, which I already explained to you, is the initial velocity. If you're hitting up, is positive. If you're hitting down, is negative. If you're shooting sideways, so it's not going up or down, the initial velocity is 0. So the example they give you, a juggler is tossing a ball into the air, which means they're throwing it up at 4 feet above the ground with an initial velocity of 40, and we want to know when it falls back to 3 feet, which means we have h is equal to negative 16t squared. That never changes. We're going to do plus 40t because he's throwing it up 40 feet a second, so it's an upward velocity of 40, and the initial height is 4 feet. That's how high his hand was when he tossed it. And we want to know when the ball is at 3 feet. So we want the h to equal to 3. To solve for this, we have to turn it into standard form by moving that 3 to the left side. So minus 3 on both sides becomes plus 1 equal to 0. And then you end up with a standard form. You're going to plug in the quadratic formula, which is negative b plus minus b squared minus 4ac over 2a. This simplifies to negative 40 plus minus square root of 1664 over negative 32. Punch this into the calculator, you end up with negative 0.025 or 2.5 seconds. Now, we know that time cannot be negative, so in this case, the time when it goes up from 3 feet and falling back down to going up from 4 feet, falling back down to 3 feet is exactly 2.5 seconds. If you graph this, given this is the height, and this side is the time in seconds, what that will look like is 1, 2, 3, 4. He's throwing the ball up and coming back down at 3. So this is a point where it's 3 feet at exactly 2.5 seconds. The reason why there's another solution negative is because it's also 3 feet high if you somehow can move backward in time, but in this case it doesn't apply because the ball doesn't start going until s equals to 0. So the only time that makes sense is when the ball is flying in the air at 2.5 seconds. Okay, I know that I'm going by this pretty quickly. I will answer questions in class tomorrow. Here is the homework that is due on Wednesday, so you don't even have to start on it tonight. If you want to get started, it's up to you. But I will give you the entire class time tomorrow to work on this and answer questions. And this is due on Wednesday. Thank you for watching.